Good morning, friends. All right, so today we are starting lesson 4, which is Gaussian elimination, and we're going to start by defining some words. So the first word is Gaussian elimination. This is just another method for solving linear systems. Okay, so we're going to use this method to solve linear systems. Just like substitution, elimination, these are both methods we can use to solve linear systems. We're going to use Gaussian elimination as well. Number 2, we're going to use Gaussian elimination by setting things up into augmented matrix. And an augmented matrix is a matrix form of a linear system obtained from the coefficients, and remember coefficients are the numbers in front of variables, by the coefficient matrix and a constant matrix. And constants are numbers by themselves, right? Constant matrix. Okay, so for example, if I have a system 2x minus 3y equals 8, 4x plus 5y equals 1, I can set up this augmented matrix by matrices have these brackets around them and they have numbers inside of them, okay? So I'm going to take the coefficients and set them up in a matrix. So the coefficients of x will go in the first column, coefficients of y go in the second column. Then we're going to have a bar, and then we'll have our constants. So we have a 2 is our x coefficient of the first system. Negative 3 is the coefficient of the y. And then 8 is our constant. Then we have 4 is our coefficient of x. 5 is our coefficient of y. And 1 is our constant. So what this is saying is basically that we have x plus y. This bar is kind of like an equal sign, our constant over here. So we just took the coefficients and we made a matrix out of them. This is called the augmented matrix. All right, so number 3, our next definition. Actually, you know what? Yeah, number 3. Row echelon form. Is a matrix form used when solving systems with ones in the diagonal. So when we're solving systems, our goal is to get it into row echelon form, which would mean I would take my augmented matrix and I'm going to perform row operations. We'll define those in a minute to get to where I have ones in the diagonal. It doesn't matter what this equals over here. I guess I'll change these 5 and 4, whatever, to where I have ones in the diagonal. So my goal here is to get ones across the diagonal there. Okay, I'm going to scroll. Oops, let me just. There we go. All right, then our next definition that we have is row operations. And these are methods used to transform matrices. Okay. So what I want you to do is look up the 3 types of row operations. Look up the 3 types of row operations and write them down. And then I want you to come back up into this second slide, and I want you to set these up. Do this part right here. Set these 3 examples up in augmented matrices. All right, that's all we're going to do today. So look up those 3 row operations and then set these 3 matrices up in augmented matrix. All right, I will check those with you tomorrow in tomorrow's video.